Okay, these notes, if you haven't already, on a blank sheet of paper or up on your next blank page, write the title up top. This says Arithmetic Sequences.
Oh, arithmetic.
Oh, that's cool.
The same word as arithmetic in arithmetic. Arithmetic is a noun. Arithmetic is an adjective describing sequences. Fancy. Okay, the definition, let's start with this. What you need to know is sequences are just a pattern of numbers, which you have messed with before. Arithmetic means adding and subtracting, so it's just a pattern of numbers where the pattern is adding or subtracting. Okay, and really there's no such thing as subtraction. We've talked about that before. If you're subtracting, you're actually just adding a negative number. So an arithmetic sequence is a pattern where each term is found by adding or subtracting a number or a constant. One vocab phrase you need to know is whatever you're adding or subtracting by is called the common difference. Okay, all right. These two formulas, explicit rule and recursive formula, these are two ways that we can just model the pattern. What I mean by that is, instead of writing out infinity numbers, 18, 16, 14, 12, 10, for infinity, we can just write an equation that represents that pattern, and we can use that equation to help us find future terms. Okay, I don't know why there's two. I wish there wasn't two. The explicit one is the one we use the most, because the explicit rule is one that you can use to find future terms. The recursive rule, you cannot use it to find future terms, which we'll get more into in a second. Okay, but you do need to know both because they both exist, so we'll talk about both. All right, example one. It wants us to write the explicit formula and the recursive formula for the following sequence. In order to write the explicit formula, I'll start with that one. I only need two pieces of information. I need to know what the common difference is, which is D, highlighted in blue, and I need to know what the first term is, which is A sub 1, and that's how you say that. Small number in the corner is A sub 1. A sub 1 is referring to the first term, duh. Okay, A sub 2 is obviously the second term, A sub 3, and so on. So if you look down at the next question, it's asking us down here to use the explicit rule to find the 45th term. We're going to write A sub 45 for that because it's referring to the 45th term. All right, so let's start this. I just need to figure out what the common difference is and what the first term is, plug it into this formula, and then I'm good. So, common difference is we use lowercase d. Okay, and I can just tell by looking. It goes from 18 to 16 to 14 to 12. It's getting smaller by 2 each time, so my common difference is -2. I am adding -2 each time. My first term, hopefully it's super obvious and easy to find because it's just the first one given. My first term is 18. Okay, once I have those two pieces of information, I'm just substituting them into my formula. So I'm going to do the explicit one here. All right, and so A sub n is how we say that, equals, the common difference is -2. Okay, I always have parentheses, n minus 1 in here, and then I'm adding the first term, which is 18. And n is just referring to like what number term we're talking about. So later when we're finding the 45th term, we'll do A sub 45, and then n will be 45 because that's the 45th term. All right, when I write the recursive rule, which I'll do over here, it still starts with A sub n, same thing. And it always has A sub n minus 1 next to it. Okay, so I'm always just going to fill in A sub n minus 1. And all that's saying is the term before A sub n. So let me put this in terms with numbers here. If I wanted to find the 7th term, the front would say A sub 7. Okay, and then equals A sub 7 minus 1 would obviously be 6. So what this is saying is in order to find the 7th term, you look at the 6th term, the one before it, and you just add the common difference to it. Okay, so that's all we're saying here. So we have A sub n equals A sub n minus 1, and then I'm adding the common difference. But instead of plus -2, I'm just going to write -2 because it means the same thing. All right, with the recursive formula, we do always have to write what A sub 1 equals. This is our pattern, and then we have to say A sub 1 equals 18. So 2 parts to that recursive formula. All right, so both of those are a model that represents this pattern, but in the next step, only the explicit rule can we use to find a future term, so the 45th term. Okay, so we are going to use the explicit rule to find the 45th term. Here is how this works. I am going to do a sub 45. That's the 45th term. Equals -2 times, n is talking about which term we're talking about, so I'm plugging in 45. It's always got -1, and then in this case I'm doing plus 18. Now if I simplify this out, it will tell me what the 45th term is, which is way better than writing out 45 terms in a row to see what it is. Okay, so I'm just going to keep this out front. A sub 45 is equal to -2 times 44 plus 18. A sub 45 is equal to -88 plus 18, which means that the 45th term, A sub 45 is equal to -70. So if we wrote out the first 45 terms, that 45th one would be -70. Okay, example 2 is more like an Algebra 3-4 honors problem. The first one, I usually start kind of basic to show you the vocab and show you how things work, and then the next examples usually make it more difficult and more like an Algebra 3-4 honors problem. All right, but I've got to do the same thing. I've got 3 things I've got to do. I've got to write the explicit rule, I've got to write the recursive rule, and I've got to find the 26th term. I'm going to find the 26th term last because I'm going to use the explicit rule to find the 26th term. So I'm going to write both my formulas first, and then I'm going to use that to find the 26th term. All right, this problem is obviously a little bit harder. You cannot see the first term. It gives you the 6th term, and it gives you the 10th term. You cannot see the first one. And you can't easily see the common difference. In the previous problem, we just looked. It went from 18 to 16, so it dropped by 2. Went from 16 to 14, it dropped by 2. Here, you can't just look at numbers right next to each other and see what's happening. So we are going to do this. To get from 22 to 14 in this span of time, I dropped by 8. Okay? So in this span of time here, from 22 to 14, I dropped by 8, so I'm going to write -8 down here. And this example is pretty basic. When I put bigger numbers in there, it gets a little more complicated. But the next thing I need to know is, like, how many steps did I take to get from A sub 6 to A sub 10? So to get from here to here, that was 4 steps. Okay, A sub 6 to A sub 7, to A sub 8, to A sub 9, to A sub 10, that was 4 steps. And along those 4 steps, I did a total of dropping by 8. So if I divide -8 divided by 4, then that means each step I dropped by 2. So my common difference, and I'll write it using lowercase d, is -2 again. And it's not always -2, it just happened to be that way in these 2 examples. All right, I still don't know my first term, but no problem. I know what the pattern is. Going to the right, I'm dropping by 2 each time, so hopefully it's common sense. Going to the left, I'm adding 2 each time. So I could just take A sub 6, add 2, add 2, add 2, add 2 until I get back to A sub 1. That would really suck if this was A sub 60 though, right? Because then you'd have to do that like 59 times. We want to avoid that. So instead what I'm going to do is I'm going to say, okay, from A sub 6 to A sub 1 is a total of 5 steps. And I know that each one of those steps going in that direction, I'm adding 2. So if I'm adding 2 5 times, that's 5 times 2. So from here to here is going to be adding 10. All right, so from 22, this is going to be 32. So down here, I know my common difference is -2, and I now know A sub 1 is 32. That is the information that I need to be able to write my formulas. Yeah?
How did you get -2?
The question is, how did I get -2? I noticed that from here, from 22 to 14, I subtracted 8. But I know that from A sub 6 to A sub 10, I did a subtraction 4 times. From A sub 6 to A sub 10, there was like 4 steps in there. So I did the same thing 4 times. But if I know that it did -8 over 4 equal increments, then I know that it dropped 2 each time. All right, so I'm going to start with my explicit rule. Okay, A sub n equals, my common difference is -2. It always has an n minus 1. And then here, I am adding 32. Okay, real quick, one thing that you're going to see when you do your assignment on Alex, or if you're looking on a different internet site or in a math textbook, Some people put a sub 1, that 32, in the front. So it could say a sub n equals 32 minus 2 times parentheses n minus 1. Do not let that confuse you. All right, it can be in the front or in the back. All right, my recursive rule is a sub n equals a sub n minus 1. It always starts off that way with recursive, and then I just need to add or subtract the common difference. So I'm going to do minus 2 back here. And I've got to say what the first term is. The first term is 32. So there are my two rules. Okay, but the directions ask me to do three things. It asks me to write the explicit, write the recursive, and find the 26th term. So to find the 26th term, I'm going to say a sub 26, that's referring to the 26th term, equals negative 2 times the 26th term, that's going to be n, so 26 minus 1, and then I'm going to add 32. Okay, so the 26th term equals negative 2 times 25 plus 32. The 26th term equals negative 50 plus 32. And the 26th term is negative 18. So I've done all three things. Found the 26th term, wrote the explicit rule, wrote the recursive rule. That is your arithmetic sequences lesson.